Alright, this is target 1H, finding the domain. So again, generally speaking, the domain is negative infinity to positive infinity, or all real numbers. Okay, there are just a couple of problems areas, and those problem areas are when there are even roots, you can't have a negative, and when you have a fraction, you can't have a zero in the denominator. So looking at this first problem, the issue is that we have an even root. This is an even root because the index is 6. So whatever's under the root has to be positive or not negative, so it could equal 0. So I just take what's under the square root and I say that has to be greater than or equal to 0. And I'm always going to say greater than or equal to 0. It doesn't matter what else is happening over here. I'm going to say greater than or equal to 0 because it has to be bigger than or equal to 0 to go under a square root. So now I'm going to subtract 2x. I have negative 3x is less than or equal to negative 2. Then I have to divide by negative 3. But now warning bells should be going off in my head. I am dividing by a negative. So when you divide by a negative, you have to take that sign and flip it over and make it face the other way. Anytime you multiply or divide by a negative. Now I didn't have to do it when I subtracted the 2, only when I multiply or divide. So now this says x has to be less than or equal to 2/3. So if I get this, I get at least a 4 on the problem. Okay, to get a 5, I actually have to put it in interval notation. To help facilitate that, I'm going to draw a number line. So here's 2/3. And this side of the number line is negative infinity, and this side is positive infinity. Okay, so this is saying start at 2/3 and go less than, so go that way, right? So this is negative infinity to 2/3, so negative infinity to 2/3. Now, negative infinity is always open, and we said it could equal. So we can say closed on the 2/3. So that's the answer, negative infinity to 2/3. Okay, the next problem is a fraction. And the problem with fractions is whatever's in the denominator can't be 0. So I'm just going to write that. I'm going to say, all right, x minus 15 cannot be 0. So I'm going to solve that. I'm going to add 15. And I'm saying x cannot equal 15. So now I'm going to draw that on the number line. And here's 15. And this side of the number line is negative infinity, and this side is positive infinity. So I have to say all the numbers in the world will work except for 15. I should say all the real numbers in the world will work except for 15. So I have to say all the numbers before 15, so that's this part. So that's negative infinity to 15. So negative infinity is always open. It can get super close to 15, so I can't say 14 because 14.9 would work, and so would 14.99 and 14.999. So to get that, to say I can get as close as I want to 15 without actually touching 15, I'm going to use an open bracket. And then union, so because I have more than one answer, now I have to say this side of the number line. So everything from 15 to infinity. So again, I'm going to do 15 to positive infinity. Infinities are always open brackets. And again, anything bigger than 15 will work, just not 15 itself. So 15.00001 would work. Okay, so I'm going to say anything bigger than 15, so open. Okay, and that's the answer. Okay, and problem number 3. Again, we have a fraction, and for a fraction, we just don't want the denominator to equal 0. So I'm going to say that. I'm going to say x plus 12 plus 4x minus 45 cannot equal 0. To solve this, I'm going to factor. So x and x gives me the x squared, and 45, there's a bunch for 45. 3 and 15, 9 and 5, I need 4, so 9 and 5 is going to be the winner there. And I need a positive 4, so I need a positive 9 and a negative 5. So let's just double check. This is going to give me negative 45. This is going to give me a positive 9x and negative 5x for a 4x. So now I'm going to set each of those not equal to 0. So x plus 9 does not equal 0. And x minus 5 does not equal 0. And I get x cannot equal negative 9 and x cannot equal 5. So now I'm going to put these on the number line. Now it's important that I put whichever one comes first. So which comes first? It's hard to see this negative, but this is a negative 9. So negative 9 comes before 5. So negative 9 first and then 5. And this side of the number line is negative infinity and this side is positive infinity. So I have to say all the numbers because every number works except these two. Every other number, every other real number works except these two. So I have to say all but these two. So I'm going to say all the numbers between negative infinity and negative 9. So negative infinity to negative 9. It's always open on the infinities. And then we're saying it can't equal negative 9, so it has to be open. Now I have to say all the numbers between, so that was this. And I have to say all the numbers between negative 9 and 5. So that's negative 9 and 5. So again, open on both of these, and now I have to say all the numbers after 5. So union 5 to infinity. Infinity is always open, and it can't be 9 or 5. So 5 has to be open, and these had to be open because it can't be negative 9 or 5. So that's it. Okay, so you have 3 more practice problems that you need to do. You need to show them either to myself or to a math lab teacher before you're eligible for the retake. So here's the first one. You need to find the domain. Here's the second one. Again, you're finding the domain. And the third one. And again, you're finding the domain. Good luck.